Hello, my dear students. Welcome to Prep Yourself. So today we are going to solve the NCERT exercise questions of chapter number 8, that is measurement of time and motion. So let us quickly start. Our first question is calculate the speed of the train that travels 150 meter in 10 seconds. So the distance given to you is 150 meter and the time that is given to you is 10 seconds. And you have to express your answer in kilometer per hour. So let us quickly see how we can solve this. All right. So what is the distance given to us? Distance is equal to 150 meter. Time is equal to 10 seconds. Okay. And what do we need to find? The speed of the car. So that's a question mark. What do we know? We know what is the formula for speed? It is distance covered upon time taken. So distance upon time. All right. So the distance is 150 meter upon 10 seconds. So we cancel this and what do we get as the answer? 15 meter per second. But we don't want answer in meter per second. We want answer in kilometer per hour. So remember student, whenever you have to convert meter per second to kilometer per hour, what do? You multiply it with 18 upon 5. Okay. So at the end of the video, I will show you why 18 upon 5. Okay. So first, let us solve all the questions. And remember that whenever you have to convert from meter per second to kilometer per hour, what do? You multiply the answer of meter per second with 18 upon 5. So let us do that over here. We have 15 meter per second. You have to convert it to kilometer per hour. So you multiply it with 18 upon 5. So 15 into 18 upon 5. 5 ones are 5 threes are 18 threes are 54. So now you get the answer as 54 kilometer per hour. So this is your answer. All right. Now let us quickly move on to the next question. I hope you all have understood this. If you have any doubt, please put it in the comment section. All right. So now going back to the next question. A runner completes 400 meters in 50 seconds. There's another runner who completes the same distance in 45 seconds. Who has a greater speed and by how much? So in this question, there are two runners. Both are covering same distance of 400 meter. One is taking a time of 50 seconds and another one is taking a time of 45 seconds. Now what do we need to do? We have to find the speed of runner 1 and then you have to find the speed of runner 2 and then you have to see which one has a greater speed and by how much. Okay, so let us quickly go to our solution board. Next page. What is given to us? Suppose we take runner A and runner B. Okay. So the first runner is having a distance, is covering a distance of 400 meter. And the second runner is also covering a distance of 400 meter. The first runner is taking a time of how much? 50 seconds. And the second runner is taking a time of 45 seconds. All right. So what do? We find the speed. The formula for speed is distance upon time. All right. So the distance given to us is 400 meter and the time that is given to us 50 seconds. Same goes over here. Speed of runner B. Distance covered by runner B upon time taken by runner B. Okay. So distance is 400 meter and time taken is 45 seconds. All right. So if you solve this, what do you get? 0 and 0 we cancel out. 5 ones are, 5 eights are. So 8 meter per second. When we calculate the distance by runner 2 or runner B, how do we do? For 400 by 45. So if you calculate this distance after all the calculations, you will see your answer is 8.89 meter per second. Okay, take the multiple of 5. So 5 nines are 45 and 5 80s are 400. Now divide 80 by 9, you get 8.89. So we know that runner 2 or runner B is faster than runner A, has more speed than runner A. Okay, so speed of runner B or runner 2, whatever, is greater by 0.89 meter per second, right? Approx. And how do you get this 0.89? You see, the speed of runner A is 8 meter per second. The speed of runner B is 8.89. So how much ahead is runner B from runner A? So what do you do? 8.89 minus 8. So that leaves you with 0.89. Clear? Understood, everyone? Now let us go to the next question. So we have done number 2. Number 3. A train travels at a speed of 25 meter per second and covers a distance of 360 kilometer. How much time does it take? So speed is given to you and distance is given to you. Let us go to our working board. So speed is given to us. How much? Speed of the train is 25 meter per second. And what is the distance covered by the train? The distance covered is 360 kilometer. What do they ask us to find? The time taken by the train. So students, remember, whenever you are solving a numerical, make sure your units are same. If you see the unit of speed, it is meter per second. Whereas if you see the unit of distance, it is kilometer. Okay, so you have to convert the distance in SI unit, that is in meters. How do we do? We multiply it with 1000. So what do we get? 360,000 meters. All right. Now, we know, what do we know? We know the formula for time. So what is the formula for time? The formula for time is distance upon speed. Right? I have already discussed all the formulas in my lecture. If you still face a problem, please feel free to put it in the comment section. So distance upon speed, 360,000 meter by 25 meter per second. All right, so your meter and meter gets cancelled out, and if you take 25 and cancel this out, you are going to get 14400. How do you get it? Just divide 360,000 with 25. Okay, so the first one will be 25. So 6 minus 5 is 1, 3 minus 2 is 1. Then 1 0 comes down like this, and then you go ahead with it. Okay, 25 fours are 100. Again, you get 10 over here. 1 0 comes down. Again, 25 fours are 100. And then we have 2 zeros left. We copy it as it is. All right, so you get 14,400 seconds. All right, you can convert this to minute, you can convert this to hours. How can you convert it into minutes and hours? I'm showing you. You can leave it to seconds also, no problem. But if you want to convert, what do you do? 1400 divided by 60. So once you divide it with 60, what do you get? You get 240 minutes. Now, if you divide 240 by 60, so what do you get? 4 hours. All right. So the answer is either you can leave it in seconds or you can convert it to hours. All right. Now, let us go on to our next question. Number 4. A train travels 180 km in 3 hours. You have to find its speed in kilometer per hour and meter per second. Also, you have to find what distance it will travel in 4 hours if it maintains the same speed throughout the journey. All right. So let us go to our solving board. So this is the fourth question we are doing. What is given to us? We know that the train is traveling with a distance covered 180 kilometer in time 3 hour. All right. You have to find the speed firstly in kilometer per hour and secondly in meter per second. So the first one, speed is equals to distance upon time. Okay, so distance is how much? 180 kilometer and time is 3 hour. All right, so 3 ones are 360s are. So 60 kilometer per hour. Now, if you want to convert this 60 kilometer per hour to meter per second, remember I just told you if you want to convert meter per second to kilometer per hour, what do you do? You multiply it with 18 upon 5. Same way, if you want to convert kilometer per hour to meter per second, what do? You multiply it with 5 upon 18. Why these numbers? I told you I will discuss at the end of the video. Okay, so for now we have to convert from kilometer per hour to meter per second. So what do? We multiply 60 with 5 upon 18. All right. If you do this, you are going to get an answer of 16.677 meter per second. Okay, this is my calculation. Please redo yourself and check the calculation. Okay. So now in our third part, what do we need to find? We need to find the distance. Okay. We need to find the distance. When the same speed is maintained, all right, then what will be the distance covered? All right. So to calculate the distance, the formula is speed into time. Now, if the train maintains the same speed of 60 kilometer per hour, then how much distance it will travel in 4 hours, right? So here we have the speed of 60 kilometer per hour and the new time which we have is 4 hours, right? So what do we get? 240 kilometer. R and R get cancelled. 60 into 4 is 240 kilometer. So that is our answer for the third part. All right. I hope you all have understood the steps. Now let us go to question number 5. Question number 5 says, the fastest galloping horse can reach the speed of approximately 18 meter per second. How does this compare to the speed of a train moving at 72 kilometer per hour? So now we have two speeds. One is 18 meter per second and the other one is 72 kilometer per hour, and you have to compare them. So remember, whenever you have to compare two same things, then you have to have it in the same unit, right? If this is 18 meter per second, get this also to 18 with meter per second. Or if you want to convert this to kilometer per hour, make it into the same unit. All right. So let us see how we can do it. So what do we have? We have the speed of the train. How much is given to us? 18 meter per second. Then we have the speed. Sorry, this is the speed of the horse. Speed of the horse, 18 meter per second, and speed of the train is given to us 72 kilometer per hour. I told you have to convert and make it into the same unit. Okay, so in the beginning also I have told you to convert meter per second into kilometer per hour. What we need to do, we have to multiply it with 18 upon 5, and to convert kilometer per hour to meter per second, what we need to do, you have to multiply it with 5 upon 18. So here 72 kilometer per hour, we have to convert it to meter per second. So we do 5 upon 18. 18 ones are, 18 fours are. So this gives us 20 meter per second. All right. Now you compare the speed of the horse with the speed of the train. You see that the train is 2 meter per second faster than the speed of the horse. So what are you going to write? The train is faster by 2 meter per second than the fastest galloping horse. All right. Now, let us move on to our next question. Our next question is question number 6. Distinguish between uniform and non-uniform motion using the example of a car moving on a straight highway with no traffic, and then a car moving in a city traffic. Okay. So, uniform and non-uniform motion, I have already discussed with you in the chapter. What is uniform motion? If an object covers equal distance in equal interval of time. How much? Equal distance in equal interval of time. Then it is said to be uniform motion. Okay, and non-uniform motion, when an object covers unequal distances in equal interval of time. All right, so non-uniform, unequal distances in equal interval of time. Okay, now if we compare these two with the help of the example of a car that is moving on a highway with no traffic and a car that is moving in a city traffic, what do we say? If we are talking about uniform motion, then a car moving in a straight highway with no traffic is an example of a uniform motion. Okay, so here this car, because it does not see any traffic, it is covering equal distance in equal interval of time. It is moving with uniform motion. It is moving with uniform speed. All right. Whereas when we talk about a car that is moving in a city traffic, it has a lot of obstructions, because of which its speed is continuously changing, and hence it is moving unequal distances in, or covering unequal distances in equal interval of time, and it is an example of a non-uniform motion. All right, now coming to question number 7. Here you have a data for an object covering distance in different interval of time. You see, time is given to you, and with the time, distance is also given to you. Okay, so what you need to do is you have to fill in the gaps over here, okay, in the table. So let us see how we can do this question. So question number 7. If you compare, sorry, let me go back to that. If you compare, at 0 seconds, the distance is 0. At 10 seconds, the distance is 8. And at 20 seconds, what will be the distance? What we can say, if it is in uniform motion, it will cover equal distance in equal interval of time. So here in 10 seconds, 0 to 10, that means in 10 seconds, it has covered 8 meter. So another 10 seconds, 10 to 20, another 10 seconds. It will cover another 8 meters. So 8 plus 8, 16. Okay. Then 20 to 30. Again, you see, add 8 to it, it is 24. Now in another 10 seconds, that means at 40 seconds, another 8 meter. 24 plus 8 is 32. Then another 10 seconds, 32 plus 8 is 40. Then another 10 seconds, 60. So 40 plus 8 will be 48. So you see, every time for another 10 seconds, we are adding 8 meter to the distance. So here, remember, whenever there is equal distance in equal interval of time, that is in uniform motion. Okay, so equal interval of time, there will be equal distances covered. All right, now going to question number 8. A car travels or covers 60 kilometer in first hour, then 70 kilometer in the second hour, and 50 kilometer in the third hour. Is the motion uniform? Justify your answer and find the average speed of the car. So if you observe the pattern, in 1 hour, it has covered first hour 60 kilometer. In the next hour, 70 kilometer. That means 10 kilometer is added in 1 hour. Okay, then in the third hour it is 50 kilometer. That means it decreases its speed. That means this is a non-uniform motion. So this is an example of, question number 8 is an example of non-uniform motion. All right, find the average speed of the car. So now let us find the average speed of the car. You know the formula for average speed we have already discussed in our video. What is the formula? Total distance covered upon total time taken. Okay, so the total distance covered, if you see, 60 plus 70 plus 50 by total time taken is 3 hours. Okay, so 60 plus 70 plus 50 is equal to 180 kilometer in 3 hours. So your answer is the average speed is equal to 60 kilometer per hour. All right, so this is our answer. Now let us go to the next question, that is question number 9. Which type of motion is more common in daily life, uniform or non-uniform? Provide 3 examples from your experience to support your answer. So in our daily life, we seldom see uniform motion. Which one is the most common one? Non-uniform motion. In our daily life, most motions are non-uniform in nature. Because why? Because objects do not move at the same speed all the time. Their speed changes due to factors like traffic, rough roads, uneven roads, and other obstacles. All right. So the motion in our daily life which we observe is non-uniform in nature. Answer will be non-uniform motion. Okay, the reason is, again, as I told you, due to traffic, due to rough and uneven roads, due to other obstacles, the speed does not remain constant. It continuously changes with time. All right, now can you give 3 examples to support your answer? Suppose we have a person walking through a crowded market, a train traveling from one place to another, a traveling bus on an uneven road, a traveling car on an uneven road. Okay, then suppose a vehicle moving in a city traffic. So there are many examples that you can give from your daily life. Now let us move on to question number 10. Data for the motion of an object are given in the following table. Okay, state whether the speed of the object is uniform or non-uniform. So let us see whether it is uniform or non-uniform. So you see time, this is 10 seconds. The distance is 6 meter. For another 10 seconds, the distance increases by 4 and it becomes 10. right? So how much is covered? 4 meter. In the next 10 seconds, the distance covered is 6 meter. Again 10 seconds, the distance covered is 21 minus 6, that is 5 meter. All right, in the next 10 seconds, 29 minus 21 is 8. Similarly, if you calculate at each step, 42 minus 35 is 7, 3, 10, 5. So equal, unequal distances in equal interval of time. So whether it is uniform or non-uniform, this is non-uniform. Remember, I told you the definition of non-uniform motion. It covers unequal distances in equal interval of time. All right. So I hope this part is clear to all of you. Now, you have to find the average speed. How do you find the average speed? I just discussed with you total distance by total time taken. All right. Now, let us come to question number 11. A vehicle moves along a straight line and covers a distance of 2 kilometers. In the first 500 meter, it moves with a speed of 10 meter per second. In the next 500 meter, it moves with a speed of 5 meter per second. With what speed should it move the remaining distance so the journey is completed in 200 seconds? And you also have to calculate the average speed of the vehicle for the entire journey. Okay, if you have not understood the question, please read it again. And now let us solve it. So that's question number 11. What does it say? It says that the total distance a vehicle moves along a straight road or line covers a distance of 2 kilometers. Okay, I'm converting it to meter. So 2000 meters. Okay, and in first 500 meter, it moves with a speed of 10 meter per second. So first this is the total distance. Let us take the total time also. 200 seconds. Okay. Now, so step 1. In the first step, we have first 500 meter. So time taken is equals to distance upon speed. Okay, so the distance is how much? First 500 meters. So 500, and the time taken is the speed is how much? 10 meter per second as given in your question. Please check your question. So you are left with 50 seconds. Okay, now step 2. Again, in the next time you calculate, so that is distance upon speed. So it covers the next 500 meters. Okay, so 500 meter with a speed of, again it covers the next 500 meters. It moves with a speed of 5 meter per second. So 5 meter per second. Okay, so 500. So this is 100 seconds. All right. So now what we say, the step 3, the remaining. Step 3. So the speed required to cover the remaining 1000 meters. See, because 500 meter and 500 meter it has covered. So the remaining is 1000 meter. So for 1000 meter, we have to find the speed of the train. So speed will be distance upon time. So what is the distance that needs to be covered? 1000 meter. So we write 1000 meter. Upon what is the time remaining? They are saying total 200 seconds. So 150 seconds it has already taken. Remaining 50 seconds. Okay. So 20 meter per second. So with what speed it should travel to cover the entire distance in 200 seconds? It is 20 meter per second. Okay, I hope you all have understood the chapter, you have understood the numericals. So that's the end of the NCERT exercise. If you face any problem with the formulas or solving any particular question, understanding the concept, please put it in the comment section so that I can help you out with the sums. Okay, thank you so much. Take care and bye bye.